All right, welcome back to another wild and exciting edition of your online geometry class. Today what we're doing is 3.3, which is proving lines are parallel. All right, so the start thinking part has to do with what we've done so far. We have this conditional statement. Remember, a conditional statement is an if-then form. This is your hypothesis part. This is the part that has to be true. So if two parallel lines are cut by a transversal, then we have all of these, which are all the theorems and the postulates. If you forget whether the different angles are parallel, or I mean congruent or supplementary, you can just draw two parallel lines in a transversal. If you look at alternate interior angles seem to be congruent, and they are. Alternate exterior angles also seem to be congruent, and they are. Corresponding angles, let's say we did this one and this one up here, they also look to be congruent, and they are. And then lastly, same side interior angles, this one and this one definitely are not congruent. This one opens up a lot, this opens up a tiny bit. If the only other option is supplementary, congruent or supplementary, then supplementary is your answer. The main thing, if you got to a test or a quiz and you forgot this, make sure you do not make your transversal being perpendicular, because then all of them are going to be both supplementary and congruent, because they're all going to be right angles. So don't do that. Once again, the theorem itself, or the theorems themselves, say if the lines are parallel, then alternate interior angles are congruent, alternate exterior angles are congruent, corresponding angles are congruent, same side interior angles are supplementary. Now, what a conditional statement is, we already talked about this a little bit in our synchronized class, but what a conditional statement is an if blank, then blank form, where this is your hypothesis and this is your conclusion. You can have math-based conditional statements, or you can just have random conditional statements. They might be true or they might be false. It doesn't matter. For example, you could say, if it is a mammal, then it is warm-blooded. That's a conditional statement. You could say, if you eat all your dinner, then you can have your ice cream. That's a conditional statement. And you can have false conditional statements, such as, if you are warm-blooded, then you are a reptile. So it doesn't matter if it is true or false, it is still a conditional statement. The original conditional statement has the if, then the hypothesis, then, and then the conclusion. The converse is when you switch the hypothesis and conclusion. Okay. When you go over and switch the hypothesis and conclusion. For example, if the original conditional statement was, if it is raining, then the ground is wet, then the converse would be, if the ground is wet, then it is raining. It doesn't matter if it's true or false. It's just, it is what it is. Now, here is the deal. In math, we come up with these different conditional statements, which are theorems, such as, if the triangle is right, then a squared plus b squared equals c squared. That is our original theorem. That's the Pythagorean theorem. Now, what they want to do is see if they can get more bang for their buck. They're wondering, is it also true if we switch these things? If a squared plus b squared equals c squared, is that then we know that the triangle is right? We'll talk about this one later on. Sometimes they're true and sometimes they are not. Okay, so the one that we're going to be looking at are all the theorems we've already talked about. We are curious if the alternate interior angles were congruent, would we then be able to say that the lines were parallel? If the alternate exterior angles were congruent, could we then say that the lines are parallel? Meaning, if we knew these things, could we then know that? Can we flip our conditional statement and get more bang for our buck out of the theorem? So when we look at this here, let's take a look. If this was a class, like normal class, what I would have done was I would have gotten a transparency piece of paper. And it says, if alternate interior angles are congruent, then what I would have done was I would have gotten a piece of paper, would have traced out this angle right here, and then I would have set it up here where the alternate interior angle would have been. Imagine that if I made this angle right here, up here, and then I extended that out, do we end up with parallel lines? We sure do. So the converse of the alternate interior angles theorem says if corresponding angles are congruent, actually this is alternate interior angles, oops, go ahead and wipe that out, sorry. The converse of the alternate interior angles theorem says if alternate interior angles are congruent, then we know the lines are parallel. So this is a way to prove that lines are parallel. Yep, we're going to be doing proofs. The next one that we're going to look at is the converse of the corresponding angles theorem. So once again, I will go over and draw that. I'm going to grab this angle and I'm going to set it up here. So I'm going to grab that angle and I'm going to set it up here. If I extend that out, if I made this angle be congruent to that angle, do we end up with parallel lines? We sure do. So if corresponding angles are congruent, then what do we know? Then the lines are parallel. The next one, converse of the same side interior angles theorem. So what I'm going to do, let me do the exterior angles first because that one's another easy one. I'm going to get this angle and I'm going to set it up here where the exterior angle would be. So what I'm going to do, actually that's not a, let me white this out real quick or erase it. White out. Okay, so what I'm going to do now is I am going to get this angle, which is an exterior angle, and I'm going to put it up here. And let's see what happens. I got that angle and I set it up here. What do we end up with? Parallel lines. So if you know that the alternate exterior angles, if alternate exterior angles are congruent, then we know the lines are parallel. Okay. And the last one is the converse of the same side interior angle theorem. If I got this angle, go ahead and white this out. Here we go. Okay, if I grabbed this angle right here, which I know is supplementary to that, and I place that angle here, making same side interior angles that were supplementary, go ahead and place it right there. This is congruent to this over here. What do we end up with? Parallel lines. So if SSIA are sup, if we know that same side interior angles are supplementary, then we know the lines are parallel. All right, so I have gone over and added this into our geometry toolbox. Let me go ahead and show you that really quickly. So here's your geometry toolbox. This is, you can't see the whole thing, but you see the most important part. Take a look. Number 14 says only when you know the lines are parallel. So this is what you would use if you knew the lines were parallel already. The converse, on the other hand, is when you are proving the lines are parallel. So if you're doing a proof and it says prove these lines are parallel, you know you're probably going to, or you're going to be using the converse, not the actual theorem. All right. Hope that makes sense. Remember to keep up your geometry toolbox because you can use that on homework and stuff like that. Let's go to the next page. Okay, so the next page is right here. It says, if we know that these different types of angles are congruent, do we know that any of the lines are parallel? So if I knew that 7 and 17, if I knew that 7 and 17 were congruent, would that tell me anything? Well, that intersection and this intersection is this line and that line, and here's the transversal. What type of angles are these ones? Those ones are SSIA, and SSIA are supposed to be supplementary, not congruent. So knowing they are congruent doesn't help me at all. This would be not enough information. If they said that 7 and 17 were supplementary, then I would have known that line 1 and line 2 are going to be parallel. But I don't know that. You have to ignore everything else when you're doing these problems. So let me go ahead and erase this stuff. So this one is not enough information because the angles they gave me were same side interior angles, and those have to be supplementary, not congruent. 21 and 20. Here is 21, here is 20. That's this intersection and this intersection, which is talking about that line and this line, and here's the transversal. Ignore everything else. These are alternate interior angles. What do we know about alternate interior angles? They should be congruent. Since they said that 21 and 20 were congruent, then I know L2 and L3 must be parallel, because those are the two lines, and here's the transversal. Okay. All right. I have to keep erasing. L2 is parallel to L3. Okay, next one. 20 and 9 are congruent. Here is 20, and 9 is over here. So that's talking about this intersection and this intersection, which must be that line, and here is the transversal. If you ignore everything else, those seem to be alternate exterior angles. What do alternate exterior angles need to be? Congruent for the lines to be parallel, and this says that they are congruent. So that means that L4 and L5 must be parallel. L4 is definitely parallel to L5. And if I had to give a reason, I think it also tells us that we're supposed to give our reason. Justify your reasoning. This one is not enough information. These ones were alternate interior angles, I believe. Let's see, 21 and 20. So this one would be the converse of AIA theorem. This one would be yes, because of the converse of AEA theorem. That's why. Let's look at 14 and 3. Here is 14, here's 3. That's this intersection and this intersection, which means that line, and here's the transversal, and everything else don't pay attention to. These are alternate interior angles. Alternate interior angles are supposed to be congruent. They told me that it's supplementary. So really, that is not enough information. This one would be not enough information because these ones should have been congruent if we were going to do something. All right, let's pan down. I'm not going to do all of these problems because I'm sure you guys are getting the hang of it. What I want you to do actually is try this one. Look at 22 and 7. Figure out if these are any special type of angles and if knowing that they are congruent helps us. 22 and 7. Figure out, are any of the lines having to be parallel because of this? If we look at 22 and 7, here's 22, and 7 is up here. That's that intersection and this intersection. That's the transversal. Those are alternate interior angles. Alternate interior angles are supposed to be congruent. Oh, they told us that they're congruent. So that means that these two lines must be parallel because of the converse of the alternate interior angles theorem. L1 is parallel to L3 by converse, and if you don't say converse, it's not right. Converse of alternate interior angles theorem. Okay. 22 and 7 alternate interior angles. Let's do another one. 19 and 11 are congruent. Here's 19, here's 11. That's that intersection and this one, which is this line, and here's the transversal. If you ignore everything else, what type of angles are those? Bottom left, those are corresponding angles. Corresponding angles are supposed to be congruent, and they say they're congruent, so yes, those two lines, L4 must be parallel to L5 by the converse of the corresponding angles theorem. And if you don't remember converse for when you're proving lines are parallel, then it is incorrect. All right, let's do one more and then we'll be done. Remember this because I'm about to delete it all. Hopefully you've written that down. Back. I need to clear up the graph. Okay, so next one, 14 and 4 are equal to 180. 14 is here, 4 is here, that's this intersection and this intersection, which means that line and this line, and here's the transversal. If we ignore everything else, these ones are SSIA. SSIA are supposed to be what? Supplementaries, and this tells us that they're supplementary. Therefore, the two lines we were looking at, L1 is parallel to L3 by the converse of SSIA postulate. If you said theorem, I wouldn't take off. Okay. All right. Now, if it said like the next one, 10 and 7, 10 and 7 aren't even connected by a transversal. So this one is just not enough information. All right, hopefully that's making sense. The steps are A, what type of angles are there? B, what should they be? Supplementary or congruent? C, if that is what they told us, then we can use the converse of that theorem or postulate. Okay, now we're going to play with the big boys. When you go over and let's see, when you go over and you are trying to do a proof, you always want to look at what it says you're going to finish with. This says we are finishing with showing that two lines are parallel. So start gaining a little information. The only way we have learned so far to prove that lines are parallel is the converse of one of the theorems. So now we have 4 and 6 are congruent, and that is given. If we were allowed to use the alternate interior angles theorem, the converse of it, we would have just done that. But this is saying prove it. So we can use anything we want except for the converse of the alternate interior angles theorem. So we're going to do a proof that is going to lead to the converse of one of these theorems. So let's go ahead and do this. First, come up with a plan. 4 is congruent to 6. Well, let's think of some things. If you had your geometry toolbox out, you're seeing 2 and 4 are congruent. This is ugly. This is don't put this into a proof, but we know 2 equals 4. 2 is congruent to 4. We also know 4 is congruent to 6 because it's given. So if 2 is to 4 and 4 is to 6, then we know 2 is congruent to 6. And if 2 is congruent to 6, what type of angles are those? Corresponding angles. If we knew corresponding angles were congruent, does that guarantee that the lines are parallel? It sure does, because the only one they say we're not allowed to use here is that one. This already gave us a hint. So let's go ahead and run through this proof. I'm going to do a two-column proof because here because it's the easiest way to do it. You want to list things in order. So yes, you could jumble these around and it's just not going to make sense. Think about that friend who always tells stories and tells things not in order. It's hard to follow them. So let's make sure this flows nicely. Even though we're given this, I'm not going to start with that. I'm going to start with 2 is congruent to 4. Angle 2 is congruent to angle 4 by that. Vertical angle theorem. Now I'm going to say angle 4 is congruent to angle 6. Why? Because it's given. Now I'm going to connect the angle 2 with the angle 6. Do you want to call it transitive or do you want to call it substitution? I'm going to do substitution. Doesn't matter. And now that we know that 2 is congruent to 6, I can finish my proof and say L is parallel to M. Since we're proving that the lines are parallel and we already know that they are, then we have to use the converse. Converse of corresponding angles theorem. And there you go. That's your proof. If we had to write this out as a paragraph proof, we would say angle 2 is congruent to 4 by the vertical angles theorem. It is given that angle 4 is congruent to 6. Therefore, by substitution, 2 is congruent to 6. So L is parallel to M by the converse of corresponding angles theorem. All right, let's keep on going. So once again, the hint that we were going to use the converse was right here. It says, hey, you're going to prove the lines are parallel in the end. So what is the only way we know? If we look at our geometry toolbox, the only way we know to prove lines are parallel is the converse of one of these things. So let's keep on going. Okay, more proofs. Okay, in this one, we are going to be proving, let me fix this real quick. Okay, in the end, we're going to be proving lines are parallel. So we know we are for sure with what we have right now going to finish with the converse of something. Don't know what the something is, but I'm going to finish with something. It looks like this one says proof using the converse of the corresponding angles theorem. So let's figure out how we're going to do this. If I know, ooh, this is tricky. So if I know, how am I going to do this? 1 is going to be congruent to 3 for sure, because they're vertical angles. Whatever, what else? 5 is going to be equal to 7 by vertical angles theorem as well, and 1 is going to be congruent to 7. So how am I going to somehow use the corresponding angles theorem? Is there any way to show that 3 is congruent to 7? If there is, then I can finish with the converse, the corresponding angles theorem. Let's see if there's any way to make 3 connect to 7. Oh, we don't even need this. Look at that. 3 is to 1 and 1 is to 7. We don't need all the other information. So if 3 is to 1 and 1 is to 7, then 3 is to 7, and those are corresponding angles. So therefore, we are going to know that we can finish our proof. Easy proof. Statements, reasons. Let's start out by saying 1 is congruent to 3. Angle 1 is congruent to angle 3 by the vertical angles theorem. Ta-da! The next one, we know 1 is congruent to 7. Angle 1 is congruent to angle 7. Why? Because it's given. See how nicely this flows? I could even have made it flow nicer by saying 3 is to 1, 1 is to 7. But this also works. And now we can say angle 3 is congruent to angle 7. I'm going to call it transitive property this time. Transitive prop. And now that I know that we have corresponding angles that are congruent in our proof, I can finish and say L is parallel to M by the converse of corresponding angles theorem. There we go. So that's a proof. You could see they gave us some other stuff. We had some things that looked kind of tricky. Those were linear pairs and they were supplementary. There's a lot of other things we could have done, but this is the easiest way we could do it. I put a bunch of information over here and I used that information to come up with a proof. All right. Now, on this one it says, if we knew for sure, or what are the values of x so that A is parallel to B? Well, this is just saying that we need to know that these things are supplementary because they're same side interior angles for these to be parallel. So it's kind of like what we just did in the last section. 2x plus 9 plus 111 must equal 180. So 2x plus 120 equals 180. 2x must equal 60, so x must equal 30. That is the value of x that must be true for this to be parallel to that. Okay. All right, when we go and look at something, let's I want to jump past this one because we're running a little bit low on time. I don't want you to have a super long lesson. Let's take a look at this one right here. This is tricky. So let's walk through this. It says that we know lines are parallel. Your hint in your toolbox, when you know lines are parallel, you're almost guaranteed going to be using one of these. Okay, so somewhere in my proof is going to be something like this. They also tell me that some angles are congruent, and in the end, we need to prove that lines are parallel. With what we have right now, we know we're going to end with the converse of one of the theorems. So we'll use the theorems with that one, and then we'll use the converse for that one. It's a harder proof, so it's a fill in the blank. So let's go through this. G is parallel to H. How do I know G is parallel to H? Freebie points. Given. Okay. Now, how do I know 1 is congruent to 3? Well, with these, 1 is congruent to 3 because they are corresponding angles. So the corresponding angles theorem says that. And I can use the corresponding angles because I've already talked about the fact that these are parallel. You have to state they're parallel before you can use the theorems. Now, how do I know that 1 is congruent to 2? Given. Now, here is where it gets a little tricky. We look. Why is 2 congruent to 3? It looks like 2 and 3 are alternate exterior angles. So it's tempting to say alternate exterior angles theorem. But what do we need to have before we can use the alternate interior angles theorem? We need to know the lines are parallel. Do we know that P is parallel to R? Nope, that's what we're trying to prove. So it must be something else. Oh, 3 is to 1 and 1 is to 2, so 3 is to 2. That would be the transitive property. And now that we have that, we can say P is congruent or parallel to R because of the converse of alternate exterior angles theorem. All right, notice once again, you cannot use the alternate exterior angles theorem until you know these are parallel. And what we're trying to do is prove that they're parallel. So make sure you do not go over and think that you can use the theorems without knowing that the lines are parallel. I think that might be it. Let me check to see if there's another page. Nope, there's no other page. All right, so that's it. So the most important things, once again, that we have in our toolbox is if you know the lines are parallel, you're going to be using the theorems. If you are proving the lines are parallel, you are going to be using the converse. Alternate interior angles would have to be congruent for you to be able to use the converse. Alternate exterior angles would have to be congruent to use the converse. Same side interior angles would have to be supplementary, and corresponding angles would have to be congruent. I hope that makes sense. Come to office hours if you have any questions. Thanks so much. Bye-bye.